Yeah, this is the X20, and actually this was probably the guitar that really took us into that more, I guess, more my era. You know, me being confident as a designer and designing things the way I felt they should be for the materials, and it was the first guitar that I started to put a lot of my own concepts into. The first thing was this sound hole. We'd messed around a little bit with different sound hole designs. Sometimes it was set up on the top, and then I just came up with this idea to have the sound hole really straddle both the top and the side. And some people had done things with sound ports on the side and things, done different placements on the top. So this was kind of a new approach to combine both.
And the other part of the idea of this is basically monitoring for the
yeah, so it's where it's positioned, it actually projects really well forward. It also projects nicely up to the player. And to me, the best thing with putting the sound hole here is it frees up all the space on the soundboard. So you kind of have a little bit more freedom on how you actually design the structure of the top. Because whenever you have a big hole cut in the guitar here, then a lot of the bracing structure is designed around making that strong again, you know, because it really weakens the whole top.
And I'm also assuming that that it also means you've got a big hole in where the area of the guitar that you want to resonate.
Yeah, yeah. So here, normally with an X brace, this area becomes very tight, but with our guitars, it's quite resonant right up in here, you know, because we can leave it looser, because we're not trying to reinforce against a hole.
And am I right in saying that there's no bracing inside these guitars?
No bracing at all. It's a completely flat panel, but it's a panel of varying thickness. So there's different areas of different strength, which can control the vibrations of the top and in turn affect the tonal properties.
Is that not really hard to do in carbon fiber, to the laying and everything of them?
Well, it's I guess it's a relatively simple process once you know what you're doing. And one of the really nice things about working with carbon fiber is it's a very consistent material. So once you create a laminate and a structure and design, you're kind of creating a recipe that you can follow, and it makes each instrument very consistent. Whereas with wood, every piece of wood is different. You know, so our raw material is very consistent, but we can actually put it together in many, many different ways to get different tonal properties, you know, depending on the layers and the thicknesses and types of resin, even how the carbon fiber is woven, the orientation of the fiber weaves. There's many different things that you can do to create different tonal properties.
Is tonal property one of the reasons behind you using, I see some of your new guitars have veneers on the front. Is that largely aesthetic thing?
It's all about aesthetics, and you know, I'm very drawn to the artistic side of guitar making and design, both in 3 dimensions on 2 dimensions. And one of the things with carbon, it's very beautiful. You know, there's a real nice 3-dimensional holographic type look of it. I think it's a beautiful material in itself, but maybe one of the feelings of it is the fact that it's very consistent. And what sometimes makes guitars nice is the fact that each one is slightly different and unique. So so just to kind of try and have an offering that allowed uniqueness within each individual guitar, we started working with veneers. And what we found is we have this great ability to use woods and veneers that you would never normally use in guitar making, because we're using them in a non-structural way.
Sure.
So we literally find the most exotic and unusual wood veneers that are on the planet, and we put them into our mold during our molding process, and under vacuum the resin that fuses into the carbon fiber also fuses right through the veneer. And the great thing about that is it makes it all one piece. It's all joined together.
So it's totally locked in. There's no structural weakness associated.
There's no weakness. It can't delaminate. It won't move with temperature and humidity. So it's a beautiful piece of wood, but you have the strength of the carbon.
Sure.
So it's that nice mix of two things, you know, the natural beauty of wood and the strength of carbon.
I suppose for me, one of the major selling points of carbon fibre guitars is the durability of them, and I'm assuming also the longevity. I mean, do you see any sort of upper limit to these guitars lasting? Or,
I guess
I've had mine for I think 6 years now, and it looks new basically. And you also use steel frets, don't you?
Yeah, I mean, I suppose how long they last is I don't know. It's beyond my lifetime for sure. You know, we've been building guitars for 20 years, and you know, some of the earliest ones are still fine, and I don't see them, you know, having a problem way beyond that. You know, it's not a material that's going to degrade. We use.
And it's sorry to interrupt. It's a one-piece molding, isn't it? Am I right?
Yeah, it's all molded in one piece, so there's no joins that are going to fail.
Including the fretboard.
Including the fretboard, including the bridge. So the carbon fibre actually runs right up over the surface of the bridge here.
I'm not even going to ask how you do that.
Well, because I won't tell you anyway. But yeah, so it's a very strong, it's a very long-lasting instrument. We use the stainless steel frets, so they barely wear. I'm yet to have somebody bring a guitar back to be refretted.